In this video, I'm going to show you two examples of how to find the area of a shaded region, which actually kind of looks like a donut in a rectangle. And so what you see is this big rectangle, and then a smaller rectangle has been cut out from the shape. So what we're going to look for is the area of the shaded region. So I want to talk to you about how to start finding the area of that shaded region. So what we're going to do is, given this rectangle below, write an expression to represent the area of the shaded region, and then I'm going to do that in standard form. So the first thing I'm going to do is talk to you about how I'm going to find the area of the donut, and how I'm going to do that is by finding the area of the large rectangle, and I'm going to subtract the area of the smaller rectangle. And the dimensions are given of your rectangle, so area of a rectangle, I'll write that off to the side, is length times width. And so what I'm going to do is find length times width of the big rectangle, or 2x plus 7 times 2x minus 7, because that's your length and your width. And I'm going to subtract my smaller rectangle's area and its length times width. And if you can see there, it's an x plus 3 and an x minus 3. So that's going to look like this. X plus 3, x minus 3. Now, with our rules of operations, Pemdas, it says multiply comes before you subtract. And so I'll just write that real quick over here. The multiply here comes before we're going to subtract, which is last. So first find the area of your large rectangle, then find the area of your small rectangle, and we're going to simplify before we subtract. All right, so let's multiply here. 2x times 2x is 4x squared. 2 times negative 7 is going to get us negative 14x. Positive 7 times 2x is plus 14x. And 7 times negative 7 is negative 49. I'm going to simplify this here because our middle terms are going to cancel out. This is 4x squared minus 49. That's the area of the large rectangle. And then we're going to subtract the area of our smaller rectangle. So I want to find that area first before I subtract. So x times x is x squared. X times negative 3 is negative 3x. 3 times x is plus 3x, and 3 times negative 3 is negative 9. Now again, you'll notice that a couple of the terms here are actually going to cancel out because 3 and negative 3 make 0. So I have x squared here minus 9. And now what I'm going to do is subtract. So subtract like terms. So I'm going to take my quadratic term and subtract this quadratic term. So if I have 4x squareds and I subtract 1x squared, I'm left with 3x squared. And if I have negative 49, because there's a subtract sign there, minus a negative 9, that's actually going to make this a plus for the 9. So negative 49 plus 9 is going to be minus 40. And this is the polynomial that represents the area of the shaded region, the large rectangle minus the small rectangle. All right, we have one more, and what it would be great is if you could try this one now that you've seen this example. Hit pause and try this one, and let's check your work. Oh, hey, welcome back. I'm so glad you gave that a try. So again, area of our large rectangle minus the smaller rectangle. We're going to do the same process. So I'm going to take length times width, so 4x plus 9 times x minus 3 this time. And for my small rectangle, I have x plus 5 times x minus 4. So what I'm going to start with is multiplying to find the area of the large rectangle. So 4x times x is 4x squared. 4x times negative 3 is negative 12x. 9 times x is plus 9x, and 9 times negative 3 is negative 27. So now if I combine these two middle terms, my large rectangle will have the polynomial 4x squared minus 3x minus 27 for its area. Now we're going to find the area of the small rectangle before we subtract. So I'm going to take and distribute here x times x to get x squared. X times negative 4 is negative 4x. 5 times x is positive 5x. 5 times negative 4 is negative 20. So now let's simplify before we subtract our areas. Negative 4 plus 5 is going to be plus 1x, and then we are going to subtract 20. Now, a helpful hint would be, if you're subtracting here, is to distribute that subtract sign. So really, I'm going to be subtracting an x squared, subtracting an x, and adding 20. And so these two polynomials I'm going to combine together now. 4x squared minus an x squared is going to give me, for my area, 3x squared. Negative 3x minus 1 more x is going to be negative 4x. And negative 27 plus 20 is going to be negative 7. And this polynomial represents the area of just the shaded region. Nice job.